Welcome to Brain Vision.
So we're given that the isotope rubidium-87 makes up 27.83% of all rubidium atoms. We're also told that the half-life of rubidium-87 is 5 times 10 to the 10 years. If we assume that no rubidium atoms have been formed since the start of the universe, and we have the total number of rubidium atoms that exist now, we want to know what percentage of rubidium atoms, or rubidium-87, in the solar system was formed 4.6 times 10 to the 9 years ago. So the first thing that we can calculate, given the half-life, is the decay constant, which is given by the natural log of 2 over the half-life. And this works out to be 4.62 times 10 to the minus 19 inverse second. So from this, we can calculate the total number of rubidium atoms present at the start of the universe using the exponential equation. Number existing now is equal to number existing at the start of the universe times e to the minus lambda t, where t is the time elapsed. Note that we want to solve for the number of atoms at the start of the universe. So dividing both sides by the exponential term, we find that m naught is equal to m to the a times e to the minus lambda t. And this is true for the radioactive isotope rubidium-87. I'll put little subscripts here to indicate that. And if you plug in the number for t at the age of the universe, 4.6 times 10 to the 9 years, you can calculate this value to be 1.0694 times the number of rubidium-87 atoms existing today. So this is the fraction greater than the number existing today that there were at the start of the universe before they decayed. So now, given the fact that only 27.83% of all rubidium atoms are currently rubidium-87 isotope, we can calculate for the number of rubidium-85 isotopes relative to the fraction of 87 isotopes. So we know the number of rubidium-87 isotopes over the total number of rubidium atoms is given by the fraction 0.2783. So we can solve for the number of rubidium-87 atoms quite easily. Just doing a little bit of algebra. This works out to be 0.2783 times the number of rubidium-85 atoms over 1 minus the same number, 0.2783, which works out to be 0.3856 times the number of rubidium-85 atoms. Solving for the number of rubidium-85 atoms, we get that is equal to 1 over 0.3856 times the number of rubidium-87 atoms. So now, for the last step, we want to calculate the fresh sheet here, our final answer, which is the number of rubidium-87 atoms that existed at the start of the universe over the total number of rubidium atoms at the start of the universe. N naught E7 plus N naught E5. So plugging in the numbers we got previously, this works out to be 1.0694 times the number of rubidium-87 atoms existing today over 1.0694 times the number of rubidium-87 atoms existing today, plus this relative fraction, 1 over 0.3856 times the number of rubidium-87 atoms existing today, using the values that we solved for previously. This works out to be a value of 0.2920. So the original percentage of rubidium-87 as a fraction of the total number of rubidium was 29%. So this is our final answer.